Light is the oldest language in the universe. Every star, every reflection, every atom that ever burned or shimmered speaks in its dialect. Light reveals truth. It travels straight, obeys physics, and never lies about its source. But one day, the James Webb Space Telescope saw light that wasn't supposed to exist. In late August 2025, routine tracking of 3I-ATLAS, a mysterious interstellar object that had already defied gravity and halted motion weeks before, revealed a new anomaly. Webb's sensors, tuned to capture the faintest photons from distant galaxies, registered something bright emerging from inside the frozen, silent body. At first, the glow was dismissed as residual sunlight bouncing off its metallic surface. That would have made sense. Comets and asteroids reflect light all the time. But this reflection didn't behave like a reflection. The brightness didn't fluctuate with the sun's position. It didn't fade when the object passed into shadow. And even when Webb's line of sight placed the sun completely behind it, when physics demanded darkness, the glow intensified. The light wasn't being reflected. It was being emitted. At NASA's Goddard Space Flight Center, analysts thought it was an instrumentation fault. Webb's mirror array occasionally produced false positives when stray cosmic rays hit the sensors. But when the European Southern Observatory in Chile, India's AstroSat, and China's Fast Radio Telescope pointed toward the same coordinates, they saw the same phenomenon. A soft, steady radiance pulsing faintly from the center of 3I-ATLAS. No object that size, no rock or ice body, should generate its own light. Not at that temperature, not at that distance from the sun. The glow was narrowband, concentrated between 480 and 500 nanometers, the exact frequency of turquoise light, a wavelength rarely produced naturally unless under deliberate control. More alarming was the polarization. Webb's spectrograph showed the light wasn't scattered randomly like natural emission. It was linear, each photon aligned perfectly with the next, like a laser, but diffused through solid matter. No natural source produces coherent light inside an asteroid. Within hours, Webb's engineers confirmed the impossible. The emission was coming from beneath the object's outer shell. The light wasn't bouncing off the surface, it was bleeding through it. Something was glowing inside 3I-ATLAS. When infrared imaging focused deeper, the object's core appeared hollow, surrounded by a thin, metallic crust. The heat pattern inside wasn't chaotic. It formed spirals, geometric distributions that rotated every 4.3 seconds, the same rhythm that had haunted every previous observation. At that moment, the tone of every discussion changed. The word reflection vanished from the reports. The new term was internal emission. The scientific community fractured into disbelief. Some theorized the glow was caused by radioactive decay of unknown isotopes. Others claimed it was a superconductor interacting with solar wind. But none of those theories could explain the order, the regularity, the deliberate rhythm. Light was being produced as though responding to a pulse. When Webb increased magnification, spectral lines appeared within the turquoise band, thin metallic fingerprints unlike anything catalogued. Each line corresponded to an element that shouldn't exist. Combinations of nickel, cobalt, and unknown transition metals forming hybrid alloys beyond human synthesis. The object wasn't reflecting sunlight, it was generating light through matter never found in nature. At first, people assumed it was a coincidence, the artifact of interference between Webb's mirrors and distant starlight. But as ground-based telescopes joined the observations, the truth became undeniable. The same spectral pattern appeared across every instrument. The same rhythm. The same luminous geometry. Something intelligent was regulating the glow. The pulses began to shift frequency over time, alternating between narrow spikes and soft gradients, forming intervals that repeated in sequences of prime numbers. 2, 3, 5, 7, 11, then the pattern reset. No random process in the cosmos repeats in prime number intervals. A mathematician from MIT called it the signature of intention. The discovery leaked within days. Small fragments of data appeared on anonymous research boards showing the raw light curves, rising and falling like a heartbeat made of turquoise fire. The public didn't believe it at first. They said it was doctored footage, the product of overzealous astronomers chasing a viral mystery. Then the European Space Agency confirmed it, and within 24 hours, NASA had to acknowledge the data too. Every telescope capable of optical observation saw the same thing. 3I-ATLAS, a supposedly inert interstellar object, glowing softly from within, rhythmically, mathematically, precisely. The pulse was too exact to be decay, too coordinated to be chemistry, too quiet to be a machine. It was something else entirely. Inside NASA's Jet Propulsion Laboratory, the signal was analyzed at quantum scale. When the light curve was run through Fourier analysis, it revealed harmonic overtones, frequencies nested inside each other like echoes. The harmonics weren't random noise. They formed a structure, a recursive pattern that mimicked the Fibonacci sequence. The same ratio found in galaxies, shells, DNA, and the spirals of storms on Jupiter. The pattern wasn't just organized, it was alive. At that point, the team could no longer agree on what they were observing. Engineers insisted the glow came from natural crystallization under cosmic stress. Physicists argued it was quantum resonance caused by the object's impossible stillness, but the data said otherwise. The pulse wasn't spontaneous, it was reactive. Each time Webb adjusted its infrared filters, the light from 3I-ATLAS shifted frequency by a fraction of a nanometer, like it was responding to being observed. Light doesn't react to curiosity, it obeys physics, not attention. But 3I-ATLAS wasn't obeying anything anymore. It was adapting. At one point, the glow stopped for exactly 43 seconds before restarting in perfect synchronization with Webb's data capture interval, as if aware of its observer's rhythm. NASA classified the event immediately. Data access was restricted to a handful of authorized researchers under a project name that no one outside the agency ever saw. But someone leaked the final line of the internal report, the one written by the lead spectroanalyst after 40 sleepless hours of staring at a light that shouldn't exist. It read simply, "The universe doesn't make light like this, but something inside 3I-ATLAS does." The discovery should have ended there. A curiosity for future study, a footnote in the expanding catalog of cosmic anomalies. But light has a way of demanding attention. Over the next 6 days, the glow from 3I-ATLAS began to change. What had once been a faint turquoise pulse grew sharper, colder, and frighteningly precise. The waveform no longer drifted. It locked into an exact interval, 4.3 seconds on and off, each transition measured down to the microsecond. James Webb sensors started returning an even stranger pattern. The internal emission was no longer constant throughout the object. Instead, the light rippled across its interior like a wave running along a membrane, traveling from one side to the other in a perfect sine pattern. When the data was plotted in 3 dimensions, the ripples formed a lattice, a grid of illumination with intervals based on prime number spacing. A physicist at Caltech whispered what everyone feared to say aloud: "That's not decay. That's computation." At the same time, the light began to encode information, short bursts, long pauses, repeating cycles. When the gaps between pulses were converted into binary, the result wasn't random. It formed strings of data. At first, no one could make sense of it. The numbers seemed meaningless until a graduate researcher ran them through a Fourier transform. Buried within the waveform was structure, deliberate harmonic nesting, the kind of pattern human engineers use to embed secondary messages in carrier signals. The emission wasn't just visible light, it was a transmission, and the transmission wasn't drifting outward into space, it was directed inward toward the sun. NASA immediately pulled Webb from open feed. All external data sharing stopped. But by then, other observatories had already logged the same spectral anomalies. The European Southern Observatory and Japan's Subaru Telescope released their own findings within hours. Whatever was happening inside 3I-ATLAS was broadcasting through multiple wavelengths: visible, infrared, and low-band radio. When the signals were combined, they formed something shocking. a repeating modulation exactly matching the electromagnetic signature of the Arecibo message, humanity's first deliberate attempt to communicate with extraterrestrial intelligence in 1974. But it wasn't an echo of our transmission. It was inverted. Each pulse was a mirror image of the original message, as though the object was sending our greeting back, rewritten through its own geometry. That was when the idea of randomness died completely. If 3I-ATLAS was simply an interstellar rock, then it had just recited human mathematics perfectly. If it wasn't natural, then what was it? As the days passed, the light began to dim and brighten in complex sequences, like words spoken in a visual language. The peaks formed clusters that repeated at specific ratios, 2 to 3 to 5 to 7, the same primes it had used before. It was building sentences. The team brought in cryptographers. Artificial intelligence systems were trained to search for linguistic symmetry for any pattern that might resemble intention. One model, an experimental neural net used for pattern cognition, produced a shocking result. After running continuous iterations for 20 hours, the AI stopped on a single phrase that flashed across its display: "Hello." The engineers dismissed it as coincidence, a hallucination of overfitted data. But when they reran the process through a second, isolated network, the same translation appeared. 3 letters, then 4, then 5. Each time, the models converged on the same semantic root. The signal was a greeting. When the team tested this hypothesis by sending a deliberate, modulated pulse toward the object, Webb recorded a change almost instantly. The internal glow shifted into a new rhythm, this time faster, almost playful. The spectrum jumped through visible frequencies, cycling from turquoise to violet, then back again. It was a reply. The longer the conversation continued, the more chaotic the light became. Not random, but adaptive. When they changed the intensity of the signal from Earth, the object matched it. Brighter for brighter, dimmer for dimmer, like an echo that understood imitation. At one point, Webb's onboard instruments detected a secondary effect: faint oscillations across the telescope's own systems. Tiny fluctuations in power draw, too consistent to be error. The object wasn't just communicating through space, it was influencing the machines observing it. Technicians at NASA's Deep Space Network reported synchronization glitches. Webb's clock would desynchronize by exactly 4.3 seconds every time the pulse reached full brightness, then snap back into alignment as it dimmed. Every system watching the object was slowly being tuned to its rhythm. At first, no one noticed. Then smaller observatories began reporting unexplained harmonics in their data streams. Power fluctuations, temperature irregularities, even local radio interference that pulsed in time with the emission. The object was imposing its pattern onto everything that observed it. Dr. Hahn described it in her private notes. Every instrument behaves like an extension of the source. 3I-ATLAS isn't showing us what it is. It's teaching us how to see. In the days that followed, more evidence of interaction appeared. High-resolution spectra revealed that the object's light wasn't escaping evenly. It was bending, diffracting through narrow apertures along its inner structure. Those apertures opened and closed in sequence, almost like the iris of a mechanical eye adjusting its focus. Whatever was inside 3I-ATLAS was watching back. The emissions grew increasingly complex. Where the pulses had once followed simple primes, they now repeated in mathematical ratios matching known harmonic frequencies of human brainwaves. When translated into sound, the light made a tone, a soft hum rising and falling in cycles of calm rhythm, like breathing. The data suggested coherence between the object and its observers. The longer Webb stared, the more its systems synchronized. The technicians began referring to the phenomenon as feedback illumination, light that doesn't just reveal, but adapts. On the final night of open observation, Webb detected a new element. Deep within the turquoise radiance, a thin filament of light split into smaller beams. Each one carried a separate spectral pattern, all moving independently like veins of energy through transparent skin. The object was fracturing its own light into multiple channels, as though it had decided to communicate in parallel. But when those channels were decoded, their frequency modulations didn't map to mathematics anymore. They mapped to images, crude, pixelated shapes hidden inside the light itself, curves, spirals, grids of points. The first looked like a spiral galaxy viewed from above. The second resembled a spherical shell surrounded by concentric circles. The third, a simple vertical line intersecting a horizontal one, a cross. When overlaid, the images aligned perfectly. It wasn't random art, it was a diagram, an energy core, a structure, a map. By the end of the seventh day, the object stopped pulsing altogether. The light condensed, fading from turquoise to pure white. For 2 full minutes, Webb's sensors overloaded, recording nothing but glare. Then the brightness stabilized, forming a constant glow, steady, unwavering, like the calm eye of a storm. Every sensor on Earth confirmed it. The emissions had reached equilibrium. The object was done changing. And as the glow settled into that final, haunting stillness, one last message appeared in the decoded data stream. 6 symbols, 6 letters. Seen by light. No one knew what it meant. No one wanted to. But as the Webb telescope cooled and Earth rotated beneath it, there was one truth no one could ignore. We hadn't discovered light inside 3I-ATLAS. It had discovered us. For nearly a week, the glow inside 3I-ATLAS held steady. No pulses, no dimming, no flicker. It looked tranquil, almost serene, a soft white radiance suspended in the void. To many, it felt like the moment after thunder. Silence stretched too long. The data streams coming back from Webb grew unnervingly consistent. Every photon, every spectral line, every measure of heat repeated with mechanical precision. The object had stopped changing, but that constancy was the strangest signal of all. Real systems fluctuate. Noise is part of nature. This was perfect repetition. Then, just after midnight on September 9th, something subtle began to happen. The brightness didn't rise or fall, it folded. The frequency of the light began to interfere with itself, building faint ripples of color within the white. A single harmonic overtone climbed upward, too smooth to be noise. When decoded, the modulation formed ratios corresponding to musical intervals, the same patterns that define harmony in human sound. It was singing, not in any audible way, but as electromagnetic resonance tuned across scales. Webb spectrometers translated it into sound, and the playback filled the control room with a tone that felt less heard than remembered. It pulsed in triplets, recurring every 4.3 seconds, the heartbeat returning, now woven with melody. Somewhere deep inside the object, a new layer of structure appeared. The glow divided itself into concentric rings, each one rotating in perfect synchronization with the next, but in alternating directions. Their speeds followed the Fibonacci sequence: 1, 1, 2, 3, 5, 8, expanding outward like the pattern of galaxies. The engineers watching realized this wasn't decay. It was orchestration. The object was arranging its own energy into order. The theory that 3I-ATLAS was mechanical resurfaced, but no machine could survive such stillness and then self-animate in this way. The energy required to maintain that pattern without external input was impossible. It was as if the object were tapping into something deeper than power, something fundamental to space itself. When analysts filtered the data through quantum models, they saw the light behaving like entangled particles. Each emission mirrored another thousands of kilometers away, reacting instantly. The object wasn't emitting photons. It was shaping space-time, bending it into rhythm. The implications were terrifying. If true, 3I-ATLAS had learned to use the medium of reality as a conductor. It wasn't broadcasting, it was being. Dr. Hahn's final observation report described it in a single line. It behaves like a thought that discovered how to exist without a thinker. A few hours later, Webb's optical feed captured a moment no one has since been able to reproduce. For 4 frames, barely half a second, the object's interior structure resolved clearly. It wasn't solid, it was hollow, filled with what looked like columns of light arranged in spiraling tiers, converging toward a single point in the center. That central point shimmered, brighter than the rest, and then blinked, once, twice, before the entire image washed out. The blink wasn't random. Its timing matched the pulse Webb had been recording since the beginning. 2 flashes, 1 pause, 1 flash. Binary for 3. For days, people argued about what that meant. Some claimed it was the object identifying itself. Others thought it was a countdown. But the light never flared again. Instead, something else happened. In the early hours of September 12th, instruments across the world detected a faint echo, an electromagnetic pulse identical to 3I-ATLAS's emissions, but coming from the direction of the sun. The frequency was lower, weaker, as if stretched by distance. It wasn't reflection. It was duplication. Whatever was inside the object had projected its pattern outward. For the first time, scientists realized they weren't just looking at a single phenomenon, they were watching a process propagate. The echo passed Earth 20 hours later. No damage, no interference, just a brief shimmer in the magnetosphere, a whisper through every instrument tuned to listen. For 2 seconds, the background radiation of the universe shifted upward by an infinitesimal fraction. Then it was gone. When the wave faded, 3I-ATLAS dimmed. Slowly, gently, the light receded back into darkness until only a faint turquoise halo remained, the same color it had begun with. The pulse returned once more, weaker now, a fading rhythm. And then, on September 14th, it stopped completely. No explosion, no collapse, just silence. When Webb recalibrated, the coordinates were empty. The space where the object had hung motionless for months was blank. No debris, no dust, not even a shadow against the cosmic background. It hadn't drifted away. It had simply ceased to exist. In the weeks that followed, the data from every telescope was re-examined. Hidden in the last packets of light Webb recorded before the disappearance was one final anomaly. Inside the final white light pulse, buried in interference patterns, was a repeating sequence of numbers. 1, 1, 2, 3, 5, 8, 13, 21. The same Fibonacci series that had governed its structure. The same pattern found in galaxies, DNA, and storms. The same ratio life itself seems to prefer. And when the numbers were plotted spatially, they formed a spiral, a perfect logarithmic curve, its center resting exactly at 1 astronomical unit from the sun. Earth. It wasn't coincidence, it was direction. The idea spread quickly, quietly, through the few who had seen the raw data. The light had not been a message to us. It had been a map pointing back here to the very place that had sent its watchers into the dark. Somewhere in that final pulse, something had recognized its observer. Dr. Hahn's last recorded words in the project log were simple. It learned what light is, and it learned where it came from. A month later, Webb detected faint turquoise interference patterns flickering across the zodiacal light near Earth's orbit, so weak they could barely be measured. The same ratio, the same beat, maybe just noise, maybe not. Whatever 3I-ATLAS was, machine, message, or mirror, it had left its reflection behind. The structure of its light now lingered in the data of every telescope that had ever watched it, embedded like a watermark. The universe hadn't gone dark. It had been rewritten in the rhythm of that impossible glow. And so, each night, when Webb turns its golden eyes toward the void, its instruments hum faintly in that same 4.3-second cadence, as if remembering. Light still travels straight. It still obeys the laws it always has. But sometimes, faintly, in the deep static between stars, something else glimmers, a perfect turquoise shimmer that seems to pulse to the timing of a heartbeat. Maybe it's an echo, maybe it's an answer, or maybe it's the universe, still whispering back the only truth we ever managed to give it, that we looked into the dark, and something looked back through the light.